And this little piece here is an operational amplifier for a thermocouple. So you just plug the thermocouple wires in on this side, and then it just makes it so it's readable by my Arduino. So then I can take the temperature in and I can use it to control the oil pump and a lot of other features. And then there's those header pins right there, and those pins go into the solderless breadboard, and then I can just go out here with wires and use those to connect very easily. So I actually ordered 3 of them, so this one here, and there's 2 extra ones, and I also got 2 more K-type thermocouples, which go up to about I think 1,000 degrees, but I need them to go up to maybe 200 or 300 degrees for what I'm doing, so I can have 3 of these in a row. And I think on the Arduino too, I can share 2 of the pins on the Arduino, and I only need like a third one to be unique for each of the thermocouples, so it won't take too many pins to have all 3 thermocouples working at the same time. And then I can take the temperature in the model inside the pipe where the sun comes in, and also at the end of the heat exchanger, and then also in the water. Just tested a thermocouple. I have this Adafruit breakout board, which works really well, and very accurate readings. The first time I tested a thermocouple, it was off by more than 20 degrees in sections, and here the most it ever got off is maybe 2 degrees. Mostly it's almost dead on. Sometimes off by like half a degree. So yeah, I just recorded it. It was all just put out on the computer, and I compared it to the oven thermometer that I have that's very accurate. So yeah, the Arduino is hooked up to the breakout board, and I have both sensors together inside this empty pot, and I just heat up the air inside the pot. Works out very well. So for the solar thermal car, I can use this data here, and I can use programming logic to control motors and pumps, stuff like that, to circulate the oil. This is my old thermocouple op amplifier circuit. So that tiny thing there is the op amp, and it'd give me pretty bad readings. I had like 20% error with this thermocouple with this setup, but that's all I had at the time, and this is the best way I could connect a little chip at the time. So it was all marked. What I'm doing now is I'm going to dismantle this. It's pretty useless now. I've moved to smaller and better things. So this is a thermocouple I have. I don't want to put it in any liquids. It's not really meant for that. It's meant for dry environments. It has a glass braiding that's good to 500 Celsius. It's not good to get liquid in that. So what I did here is I put it on just this wire, and then I have this 1/4 inch copper pipe. I put some JB Weld and clamped the end shut so it's watertight and airtight, and I just put that in a liquid with the thermocouple inside. So this wire is just to give it stability, to make sure that it slides through. When I slide that in, then I can measure the water temperature. Right now for this test, I'm just going to get the computer started. I'm going to have ice in this pot, and I have boiling water in this pot, so I'll be able to calibrate it to see if this is 100 and this is 0, and also I'm going to switch between 100 to 0 to see how fast it changes temperature. Now this copper is a great thermal conductor, but it also has a lot of thermal mass. There's a lot of material here. It takes quite a bit of energy to change the temperature, so I want to see how long that takes. So this is a graph I made of the data. I could just cut and paste the Arduino data straight into Excel. So it was at 100 in the boiling water, and I switched over to the ice water. So in less than a minute it went down, or just over a minute it went down to maybe 5 degrees. Now when I put it in the hot water, very quickly, in 1 second it jumped 40 degrees, and again within about a minute it went to that temperature. So 100 degrees in 1 minute as a thermal shock is very good, so this will work well. And this is again the thermocouple with the copper sheathing. Alright, and this is a test I did with all 3 temperatures. So I took all 3 different thermocouples and 3 different op amps and connected to the Arduino, and you get the temperature for all 3. And in this test what I did is I grabbed one thermocouple at a time between my fingers. So this is room temperature, and it warmed up with my fingers, the temperature, and then I let go of it here, and then I grab the next one. So each one of them warms up and cools down, and you can see the 3 different temperature channels. So at the bottom here is time in seconds, and here is degrees Celsius for temperature.